In descriptive statistics, oftentimes it's helpful for us to see a box plot of the data to see what the distribution looks like. Now with the box plot, we want 5 key values. We want the minimum value, we want the lower quartile, the median, the upper quartile, and the maximum value. So if we don't have any outliers in our data set, those are the values that we want to look for. So here I have a set of data and they want us to construct a box plot for this. I need to find my 5 key elements first. So our minimum value that we have, we need to look through the data set and find the smallest data value we have, which is a 27. We also will want to find the lower quartile, which is also denoted Q1, the median, which sometimes might be denoted Q2, the upper quartile, which is denoted Q3, and then our maximum value that we have for our data set. So our maximum value for our data set we can find right away by just looking through the data values and finding the biggest one that we have, which is 55. Now our data set here is relatively small. There's only 2, 4, 6, 8, 10 values in it. If you have a larger data set, you can put your data values into a computer software program or into like a graphing calculator into a list. And they have an option under the list that just is sort ascending, and that would automatically put the values in order for you instead of having to do it out by hand. But here we're going to do it by hand. So the next thing that we want to look for are the lower quartile, the median, and the upper quartile. So for these, I need to put the data set in increasing order from smallest to largest. So we have our 27, and then the next data value after that is 29. Then we have a 31, 32, 46, 47, 49, 51, 54, and 55. Now another way of ordering your data would be possibly putting it into a stem and leaf diagram. That could order your data set a lot quicker as well, especially again if you have a larger data set. Now there are different ways that you can go about finding the lower quartile, the median, and the upper quartile. So you'd want to reference your textbook to see what way they are asking you to, or giving you the information to bind your quartiles and your medians, or look at the information that your instructor has given to you about how to calculate these. But one of the quickest ways that you do, especially if you have a smaller data set, is to actually look at the definition of the median and then carry that across to the lower quartile and the upper quartile. So for example, the median we know is once we put the numbers in order from smallest to largest, it's the data value that sits in the middle of the data values. And for the median, we can actually, with a smaller data set, just kind of look and work inside from both ends to the middle data value, or we can find its position and then find the number that sits in that spot. The position of the median is to take your number of data values n plus 1 and divide that by 2. And that tells you the slot to look for your number. Now here I have 10 data values, 2, 4, 6, 8, 10. So that would be 10 plus 1 divided by 2, which is 11 divided by 2, or it sits in the 5.5 slot. That means it's halfway between the 5th and the 6th number. So I have 1, 2, 3, 4, 5. My 5th number is 46. My 6th number is 47. So my median for this data set is take your 46 plus your 47 and divide by 2. I get a median of 46.5. And I want to report that as my median. I don't want to round that value. Now, one of the ways to find your lower quartile number is to actually look at the median of the data set that's below the actual median of the entire data set. So since my median of my entire data set fell between 46 and 47, I want to think of a divider being there and finding my median of this lower portion of the data set for my Q1. So here I can visually just see that if I look at the number that sits in the middle of the data values from just marking it out from the ends, I get my Q1 is 31. And then the Q3 is the data value that sits in the middle of the upper data set, the median of the upper part. So here we'll get that value is 51. And again, there's not a steadfast rule on this, so you'd want to check with your notes from class, from your professor, to make sure which way they want you to use the calculation to get your lower quartile and your upper quartile. So now I have these 5 numbers, my minimum, my Q1, my median, the Q3, and the maximum value, and I'm ready to draw the box plot. Now to draw the box plot, you want to have a number line that's uniformly marked underneath your box plot. And I need to go from a value of 27 to 55. So let's just make our number line. And we'll start at 25 and increment by 5. 25, 30, 35, 40, 45, 50, and then 55. So notice I've tried to make sure that I have uniform increments that I've marked along a number line. Now once we do that, we want to make a box, for the box part of the box plot, that starts at Q1 and ends at Q3. So at 31, I make a little vertical mark, and at 51, I do the same. So that's the beginning of my box to the end of my box. So there's my 31 for my Q1 and my 51 for my Q3. Now in the box, I'm going to put a vertical line where the median is. So at 46.5, we're going to put a vertical line to show where the median hits. And then we just draw a horizontal line down to the minimum value. So we're going to draw a horizontal line down to 27 and a horizontal line up to the maximum value, 55. And that completes the diagram that's called a box plot.